section 3.7. Polynomials and rational inequalities. Inequalities mean greater than, less than, greater than or equal to, less than or equal to. The solution set is all numbers that you can plug in that make a true statement. So we're going to have intervals. Because we'll have infinite solutions, we need to come up with these intervals. First, we'll talk about what these mean graphically. Can you all graph this function? It's a polynomial. What's the first step usually to graph a polynomial? Zeros, sure. What else do we need? Multiplicity and end behavior. How do we determine the end behavior? Yes, leading coefficient and degree. If the leading coefficient is +1, degree is even, we know both up. It looks a lot like y equals x squared at the ends. And you find the zeros. If you factored it, what would the zeros be? Actually, you guys should be able to factor it just based on this graph I gave you. That's a good test question. Given the graph, can you factor this? X what? +2, very good. Because -2 is a 0? Is it even or odd? Even. So 2, 4, 6. I picked 4 because it's only a 4th degree polynomial. Okay, what's my other 0? Yes, x minus 0. And it's odd, right? So I'll pick my smallest odd number, 1. And then what's the next one? X minus 3 to the power odd, right? And so together it makes x to the 4th. And my leading coefficient is just 1 here because I just get 1x to the 4th. Okay, we found those zeros. We can factor it. But how do we answer this question? When is my polynomial negative? X to the 4th plus x cubed minus 8x squared minus 12x. When is this less than 0? So f of x refers to my y values. Basically, when is my graph below the x-axis? Down here, right? So which interval does corresponds to this? Yes, 0 to 3. So the interval 0 to 3, do I include 0? Do I include 3? You guys agree? Okay, that's wrong. Why don't we include them? Strictly less, right? We know it's equal to 0, and 0 is not less than 0. So if I plug in 0, it would make the whole equation 0. So because it's a strict inequality, that's why we use parentheses here. This is a really important concept because it's very detailed when we do these problems. Are there any questions about that? You understand why we're using parentheses? Okay, so how's my answer change if my function can be less than or equal to 0? Now we include 0 and 3 when it equals 0. Okay, when is my graph greater than 0? Negative what? The 0 or -2? It's -2. It's strict inequality, so I don't include -2. Union, what's next? So I'm saying this line here. And then it's above the axis here too, again, right? So that's -2 to 0. Then it turns negative, so I don't include this 0 to 3. 3 to +infinity, very good. A little bit tricky, right? I realize I messed up on the one above it. What am I missing there? Yeah, the green one. So, yeah, I'm missing the -2 here. The 0 here, right? So I should include a union. It can't be, but it can be equal to 0. That's why I missed it. Tricky. So I needed the 0 to 3, but I also need the -2 only. And we used curly braces to mean a single value, a single element. Okay, when is f of x greater than or equal to 0? Now I need to include the endpoints, right? So -infinity to where? But now I'm including the -2. So it's -infinity to -2, but include it, and -2 included to 0. So it's negative infinity to 0. If I plug the hole with the -2, I include that whole interval from negative infinity to 0 this time. And this one would be union, include 3 to infinity, because it can equal 0. All right, any questions about that? But yeah, because it can equal 0. Yeah, because of this line here. Okay. Strict inequality, don't include the zeros. Don't include the endpoints. Any other questions? For the next one, this is called a rational inequality. So this function is g of x graphed. Okay, this one's really tricky. When is g of x negative? When is it below the x-axis? For which x values? Okay, here's my x-axis. It's below here, and it's below here. So if I shaded that region on my x-axis, that would correspond to these values and these values. Yes, negative infinity to -2. Do I include -2? We don't include the 0, right? With the strict inequality. Union 2 to infinity. And you never include this one. Never include the vertical asymptote. It's undefined there. When is g of x less than or equal to 0? So now it can equal 0. How does that change my answer? We include which one? We include the -2. So this is a bracket here. What about the 2? We never include where it's undefined. So it'll always be parenthesis at 2. I think that direction. Yeah. When is g of x greater than 0? For which x values? So where is it above the x-axis? My graph here would be for which x values? Between -2 and 2. Do I include either of these? No, strict inequality don't include. Why do I write interval in front of it? Yeah, so it doesn't look like an ordered pair. -2, 2. When is g of x greater than or equal to 0? How does it change? Include -2, but we never include where it's undefined. Never include the vertical asymptote. Any questions about this? So that's how we read the graph, but we want to analytically solve this without having to graph it first. And that's what we're going to go through next. So notice the polynomial. I'm just going to point this out. This polynomial is either all positive or all negative between the zeros. Why can't it flip in the middle? So why can't it flip from negative to positive? It's continuous. It would have to have a 0 in between to flip. So if I found all the zeros, I know between them it's always positive or always negative. How can I find out if it's negative or positive? You can just plug in a point. So what's your favorite number between 0 and 3? 2.5. Just pick any point. It doesn't matter. They'll all be negative. I would probably plug in 1 because it's easier to plug in. What's 1 to the 4th? 1 cubed. -8 times 1 squared. -12 times 1. And the answer is negative what? 17. What is negative? So if I found out one of the points is negative, I know my whole function's negative under here. I can use one sample point. Because it can't flip to positive, it would have to have a 0 there. So I can do this without graphing. I just factor it, I find the zeros, and I plug in a point in each interval. Any questions about that? Okay, what do I do with rational inequalities? It can flip from negative to positive at a 0, or it can flip from positive to negative at a vertical asymptote. So I find the zeros for the polynomials. For the rational function, I find the zeros. I also find where the denominators are. Where's the vertical output? And that's the only place you can flip sign. So let's go ahead and practice solving one of these. You need to get one side to equal 0. Then you factor. We draw a number line and plug in some sample points. So how do I make one side 0? Subtract 20 from both sides. X squared plus x minus 20 is less than or equal to 0. Your book says this is your function. We'll call it f of x. What I'd like to know is what are the zeros of that function? How do we find the zeros of this function? Factor. Okay, what are factors of negative 20 that add to make 1? Okay, x minus 4, x plus 5. So my zeros are x equals 4, x equals negative 5. So I can draw my number line. Here's 0, 1, 2, 3, 4. I'm going to put 0 above that line to denote it's a 0. Negative 1, negative 2, negative 3, negative 4, negative 5. And I'll put a 0 here to denote that my function is 0 when I plug in negative 5. Okay, I have how many intervals to test? If I have 2 zeros, I have 3 intervals. 1, 2, 3. In my first interval, what's your favorite number that's less than negative 5? Wow, you have lots of... I heard negative 6. If I plug in negative 6, what do I get? What's negative 6 minus 4? Negative 10. What's negative 6 plus 5? Okay, and I don't care what number you plug in. I could have plugged in negative 100. The point is, whatever you plug in, you're going to get a negative times a negative in this interval, which makes a positive. No, I know my function will be positive in this interval. Do I want those in my answer? Do I want when my function is positive? I want when the function is less than 0. Function is less than or equal to. What's your favorite number between negative 5 and 4? Okay, go ahead and plug it in. I don't care which one number you pick between negative 5 and 4. What's 0 minus 4? Negative 4. What's 0 plus 5? And no matter what number I plug in this interval, I'll have a negative times a positive, which will make what type of number? A negative number. Do I want those values? Yes, I want where my function is negative. So I do want to include all these numbers here. Uh-oh. Okay, my last interval. What's your favorite number that's greater than 4? Sure, f of 5 is equal to, what's 5 minus 4? What's 5 plus 5? If I plugged in 100, any value in here, I would get a positive times a positive, which is what? Positive. Do I want to include those? No. So my answer is where my function's negative, which is between negative 5 and 4. Do I include the endpoints or not? Wise answer, yes. Oh no. I don't know what to do here. We include those points. Negative 5 to 4 is our interval. We include the endpoints because it can equal to 0. So we use brackets. Any questions about that? So the most important thing here is problem recognition. On a test, if you don't recognize this problem, it's really hard to answer what's the question asking for. It wants an interval where my function's negative. So what does that mean? If I plugged in a number like negative 100 into this inequality, what would I get? I would get a false statement. I would get something like that's larger than 20. If I plugged in a number between negative 5 and 4, I would get a true statement. So you found all the values that I could plug in here, and it will be true. It will be, in fact, less than 20. Less than or equal to 20. Okay, example 3. The one on the right is more difficult. The one on the left, you can just factor by grouping. So we'll do the one on the right. What's the first step here? Yes, make one side 0. So let's go ahead and add x cubed to both sides and subtract 8x squared from both sides. That gives me x to the 4th minus, no, plus x cubed minus 8x squared minus 12x greater than or equal to 0. And guess what? We can't factor by grouping. There is a greatest common factor though. X times x cubed plus x squared minus 8x minus 12. So if I want to find the zeros of this polynomial, how could I find those? If I can't factor. Yeah, division. It's a special form of guess and check. Where you use the rational zero theorem. Does that sound familiar? What are my p-values? Oh man, it's just all gone. It's been a long weekend. What are factors of negative 12? 112, 26. Okay, so plus a negative, right? 6, 4, 12, 6, 4, 3, 2, 1. What are my possible q values? That's great though, right? We want very few of those. Okay, so what are my possible p over q's? And I'll divide by 1, and I'll divide by negative 1. But no fractions, not bad. So then what do we do? What are my coefficients here? Hey, let me just double check. Are these numbers all right? Did I make any mistakes here? I really don't want to do a lot of extra work. That looks right. So which one do you want to try first? Are you guys good at guessing yet? Positive 2? Sure. So I bring down the 1. Multiply by 2. Add it with 1. Multiply by 2. Add it with negative 8. Multiply by 2. Add it. What does that mean? That means 2 didn't work because I didn't get remainder 0. Or upper or lower bounds, so we have 11 more to try. Hey, but how many of them could work? How many of these numbers could work? Up to 4 of them could work, possibly none of them. Right? My zeros don't have to be rational. Okay, what number do you want to try next? Negative what? Negative 3? Okay. 1, negative 3, negative 2, 6, negative 2. Oh, so close. No, it didn't work. Let's try another. 1, 1, negative 8, negative 12. What do you want to try? 1, 2, negative 6. Did it work? Negative 18. I'm just gonna erase this. Negative 4. 1, negative 4, negative 3, 12, 4, negative 16, negative 28. Oh, I should be crossing these out. Negative 4, negative 3. Which one did I try to? Oh, 1. All right. What should we try next? 6, 1, 6, 7. This is not going to work, right? Or what's 6 times 7? 42 minus 8. Yeah, that's not, are they? Okay, so we can cross out 6 and 12. They're all positive. Positive 4? 4. Yeah, we're not very good at guessing, huh? Okay, 4 plus 1, 5, 20, 12, negative 2, 1, negative 2, negative 1, 2, negative 6. Okay, so what does that mean? X squared minus x minus 6. Can I factor it? X minus 3, x plus 2. Is that right? Man, so we're just unlucky at guessing. Okay, x equals 3. X minus 2. We actually want to factor it. So let's write this as x plus 2. So I'm going to rewrite this problem over here. Now in factored form, it's x times x plus 2 squared times x minus 3 is greater than or equal to 0. And this is my function. I'm going to call it f of x. What are the zeros of f of x? X equals 0, -2, and +3. So I'm going to draw my number line. And I'll first draw 0, then -2, then +3. And I'll draw these long lines. So I have how many zeros? I have 3 zeros for my polynomial. And so how many intervals do I have to test? 4. It's always one more. So it's split up into 4 intervals. What's your favorite number less than -2? F of -3 would be -3 times -3 plus 2 times -3 minus 3. I would have a negative times a negative, which would be what? Negative. So everywhere in that interval, it's negative. Okay, what about between -2 and 0? Yeah, there's not too many options here, right? F of -1. What's -1? What's -1 times -1 plus 2 times -1 minus 3? Negative times positive times negative. Positive. What's your favorite number between 0 and 3? Okay, f of 1 would be 1 times 1 plus 2 times 1 minus 3. Positive times negative. I've messed up tremendously here. I forgot my square. You guys see that? This one should be squared. So that would change this to a positive. The other two are correct. So which interval is wrong? Left, middle, or right? Left should be positive. What's your favorite number that's larger than 3? Okay, sure, 4. What is 4 times 4 plus 2 squared plus 4 minus 3? Okay, all positives multiply together. Positive. So do I want the positive or the negative intervals? Where my function is larger than or equal to 0. Positive and 0. So I want to include everything to the left here. Do I want to include the 0? Yes, I want to include the 0. I want to include everything in between. I want to include the 0. Over here where it's positive, and I want to include the 0. So what is the first interval? -infinity to 0 included. 3 included to infinity. That's our answer. Every value in those intervals, if you plug it into the original inequality, you'll get a true statement. If you plug in any number between 0 and 3, it'll give you a false statement. What we're going to do next time is called a rational inequality. I just want to point out, I have 20 seconds left. What is the most common mistake? If it was an equation, what would you do here? You would multiply, right? For an equation, you would multiply. If you do this on an inequality, you'll get a 0 on the test. Don't multiply. Instead, you want to make one side 0, so you're going to subtract 4 from both sides. Step 1 was to make one side equal to 0. Step 2 is to get a common denominator. So that's what we're doing here. Well, let's simplify this. 1's greater than or equal to 0. 3x plus 1. And over here, I'm going to distribute the -4. Maybe I'll do that in different color. To get -4x plus 8. And now I have a common denominator of x minus 2. So once I do that, I can add the numerators to get, what's 3x minus 4x? -x. What's 1 plus 8? 9. Very good. Any questions about this? So that's step 2. We got a common denominator. So where can my function, this is my function, maybe I should label it f of x. Where can it switch from positive to negative or switch from negative to positive? Let's look at the graph from the yesterday. This is an example of a rational function. Where can it change from from negative to positive? So do you agree that this function is negative down here? It's below the x-axis, is negative. Where does it flip to positive? Whoops, what happened? It's covering my pens. This is upsetting. All right, technology error. Zoom, get out of my way. How do I get this box to disappear? Yes, I'm sharing my screen. I'm just gonna share again. There's an arrow? Okay, this thing? Oh, thank you. Okay, where does my function switch from negative to positive? At this thing called a zero, right? At the zeros of my polynomial or my rational function. Where else can it change from positive to negative? At this point here, which is called where it's undefined. On either side of where it's undefined, it's either all positive or all negative. So that's why we're finding these values. Where is it 0? Where is it undefined? Because in the interval to the left of the 0, it's all negative. In between, it's all positive. And to the right of the undefined value, it's all negative. So we need to find these test points. These are the important points. So I go back to the rational function. And I say, where is this thing equal to 0? Where are the zeros of this function f of x? It's where the numerator is equal to 0. Because what's 0 divided by anything? 0. We say, when is it that negative x plus 9 is equal to 0? X equals 9. Step 4, we need our number line. And I want to graph x equals 9. Here it is. I found 9, and it's a 0, so I'm going to put a 0 above it. Okay, how do I find where my function f of x is undefined? Yes. When the denominator is equal to 0. When is it true that x minus 2 equals 0? X equals 2. So I go here on my number line, and I find 2. And I'm going to label it with a big U to state that it's undefined there. Any questions about this? So you set the numerator to equal to 0. You label those with a 0. Set the denominator equals 0. You label that with a U for undefined. So I know that I have 3 intervals to test with my original function. Negative x plus 9. Maybe I'll write that over here again. F of x is equal to negative x plus 9 over x minus 2. In my first interval, what's your favorite number that's less than 2? 1? Okay. Mine's 0. I'm going to go with 0. What is f of 0? It's 9 over negative 2. But all I care about, is it positive or negative? Negative. So that tells me every other point that I plug in this interval will also be negative. All right, let's try the next interval. What's your favorite number between 2 and 9? Sure, let's plug in 3. So then we get negative 3 plus 9 over 3 minus 2. The point is, I get a positive divided by a positive, which is positive for every point in between. We plugged in 3, but we know every point in between will be the same. So this interval is positive. Any questions so far? Pick your favorite number greater than 9. Let's plug in 10. F of 10 is equal to negative 10 plus 9 over 10 minus 2, which would be negative over positive, which is negative. So I know that every value in this interval will be negative. because the only way that it can switch from negative to positive is to have a 0 or undefined. But we found all places at 0 and undefined. Okay, last step. Are we looking for the positive intervals or the negative intervals? Yes, we're looking where f of x is greater than or equal to 0, positive. So my answer is this interval here in between. What is that in interval notation? Oh, so close. Yes, not including 2, because we never include where it's undefined. That's the major difference here. Yeah, we include the 0 because it can equal 0. Okay, any questions about this? You definitely want to practice a couple of these the day before the test, day of the test. It's just different from anything else we do. Let's try example 5. What's the first step when you see a fraction and an inequality? Yeah, make one side 0. Done. Subtract from either side to make one side 0. What's the next step? Get a single fraction. You want to get a single fraction. We're done. A common denominator to make that single fraction? Yes. Okay, so step 3 would be what? We want to find the zeros and where it's undefined. Can I factor 6x squared minus 11x minus 10? Is that factorable? Shall we try stuff? 3x and 2x, factors of negative 10, so negative and positive. Negative 5 plus 2. So that would give us positive 4x minus 15x gives us negative 11x. Okay, do AC method if you're uncomfortable with guess and check. This function, we're calling it f of x. How do I find the zeros? Yes, where's the numerator equal to 0? When is it that 3x plus 2 times 2x minus 5 is equal to 0? X equals what? Negative 2/3, or x is equal to what? 5/2. Okay, where is f of x undefined? It's where the denominator is 0. X equals 0. Very good. Step 4, we draw this number line. How many intervals am I going to need to test? Not 2, not 3, 4. However many points you find, 1, 2, 3, we'll split this up into one more interval, 4 intervals. So let me plot those points. Here's 0. 5/2 would be what, 2.5? Here's 5/2 and negative 2/3. All right, let's go ahead and draw these lines up here to denote that we're splitting up this interval into 4 sub-intervals. Which one is the really important one when I label it? Yeah, 0 is undefined. And the zeros are, I'll label these with 0. Let me ask you a question. Do these have to alternate positive, negative, positive, negative? No, they don't. Because at a vertical asymptote, for instance, they could both be positive, right? But let me ask you another hypothetical question. At this one, x equals 0, does it flip from positive to negative or negative to positive? Does it flip sign there? The exponent here is 1, so yes, it does flip. All right, what's your favorite number less than negative 2/3? Okay, f of negative 1 is equal to negative 3 plus 2 times negative 2 minus 5 over negative 1. Really just gives me a negative times a negative over a negative, which is what? Which is negative. All right. This interval is negative. What's your favorite number between negative 2/3 and 0? Yeah, negative 1/3. But there's infinitely many numbers to choose from. Okay, f of negative 1/3. Negative 1/3 plus 2. I should check this. Negative 1/3 times 3 is negative 1 plus 2 is positive. Negative 1/3 times 2 minus 5 is negative. Negative 1/3 on the bottom is negative. So what's a positive times a negative over a negative? It's positive. Okay, my next interval, I know that the exponent here is odd, so my function is going to switch to negative. But I could just double check. What's f of 1, for instance? Positive, negative, positive, which is negative. Okay, what's your favorite number greater than 5 halves? Yeah. All right, 3. So that would be positive. So it's positive in this interval. Okay, step 5, are we looking for the positive or negative? F of x is greater than or equal to 0. Positive intervals. So I want this interval here and this interval here. So what's my first interval? Negative 2/3, 0. Which one do we count? We count negative 2/3 because that's a 0. And we don't count where it's undefined. Okay, union, what's my next interval? 5 halves to infinity. We include it because that's a 0. And infinity is not a number. Any questions about this? Okay, I have 2 typos here that I need to correct. This should be a 9x, and this should be a square root of this function. Okay, so this is a little review from the last test, applying it to this new section. How do you find the domain of a radical function? I think it's going this way. How do you find the domain of a radical function? Say the inside must be what? Must be greater than or equal to 0. Because if I plug in a negative, the square root of negative is not a real number. So the domain is what values of x can I plug in to get a real number? The inside of the radical must be positive or 0 to get a real number. Okay, what about this one? How do I find the domain of h of x? 3x over x plus 2 must be greater than or equal to 0. So in either case, we're going to solve either a polynomial inequality or a rational inequality. Do you want to practice either of these? Which one? I guess we could do both. What does this factor into on the left-hand side? Positive 6, negative 3? Does that work? 12, negative 3x plus 12x? Is that, yeah, that's 9x, right? Okay, so what do I want to do with that? Yeah, the zeros. What are the zeros? Very good. So I go to my number line and I say, here's negative 6. Here's 2/3. Do you want to know a shortcut? It only works for the quadratics. Is this polynomial upward facing or downward facing? That lead term is positive, right? It's upward. I found the zeros, and I know it's upward. What does that mean? Positive, negative, positive. Which intervals am I looking for? Positive. So that would be negative infinity to negative 6 inclusive, union 2/3 to infinity. Any questions about that? Yeah, if the leading coefficient is positive, it's upward facing parabola. If it goes to these zeros, it would have to have the shape. I know it's above the axis to the left, the axis to the middle, and above the axis to the right. If that was a negative 2, but you can always plug in your favorite points in each interval to double check. The next one, you make one side 0, it is. You need to subtract to do that. Next, you need to get a single fraction. We have that. So we're already able to find the zeros. Where are the zeros for this one? Negative 2 is something else. Undefined. So x plus 2 is equal to 0 is where it's undefined. What are the zeros? When 3x is equal to 0, the numerator. 0 over anything is 0. Anything over 0 is undefined. So we have 0 and -2. Has that registered to us? 0 over anything is 0. How many times does 100 go into 0? 0 times, right? How many times does 0 go into 100? Infinite times, which is undefined because infinity is not a number. Denominator 0, numerator 0. Definitely want that to sink in. So then I plot these points. X equals 0, oh, okay, thank you. -2, 0. Which one do I need to be careful about? -2, right? 0 is a 0. Do we want to do the quick way for this one, or do you want to plug in test points? Okay, but it does require a lot of knowledge from your graphing last night. Do we remember all of our graphing? Okay, so the vertical asymptote is at -2, right? What about the horizontal asymptote? Horizontal asymptote to this function here. The degree of the top and bottom is the same. Did we do the homework? The horizontal asymptote is the leading coefficients divided by each other. Y equals 3. It's a horizontal asymptote. I know I have a 0 here at 0, 0. And I just need to know, does my graph cross the horizontal asymptote or not? Does 3x over x plus 2 ever equal 3? Multiply both sides with x plus 2. Subtract 3x from both sides. When is 0 equal to 6? Never, so I don't cross it. So my graph looks like this. Why does my graph look like that? The exponent corresponding to this vertical asymptote -2 is 1. So if this approaches infinity on this side, it must do the opposite on the other side, which is positive infinity. Okay, so now I know that my intervals are positive, negative, positive. But you can always just plug in a point to check. Which intervals are we looking for? Positive intervals. So the answer would be -infinity to -2 and 0 to infinity. Do I include -2? No, it's undefined, never include it. Do I include 0? Yes, it's can equal 0.